We're going to talk right now in this video about a thing that we'll call quality. So what is quality? Well, when we think about the phase diagram, here are three different examples of phase diagrams, right? It's all the same phase diagram, solid, liquid, vapor. They're just three different ways of visualizing it. The one that we're probably most familiar with from chemistry class would be this one that I've labeled 1, where we have a distinct phase boundary between, say, the solid and liquid, the liquid and vapor phase, maybe down here the solid and vapor phase, where you have something like carbon dioxide, where you go across that boundary and you would sublime. And we're, I would say, fairly used to this. These other two phase diagrams are a little bit weird because in these we have, so I'll do this, this one that I've labeled 2. On this one we have pressure here on the y-axis and specific volume, right? How much volume or how much space a set quantity of this material takes up. So over here on the left side, this is where we would have our liquid phase. This is where we would have our vapor phase. And then here in the middle, we're going to have a mixture of liquid and vapor. So this is something that is in the process of boiling. It's like partly boiled. So we're going to introduce the term quality to help us describe this phase where we have the phase change actually happening. We're going from something over here on this line, which is entirely a liquid, to something over here on this other line, which is entirely a vapor. And we want to be able to describe all of these points in between. How much vapor do we have? How much liquid do we have? If we think to the demo that we did in class with the syringe, we had a syringe with water in it. And then when I pulled the plunger, some of that water boiled and we had a vapor phase of some volume and a liquid phase of a different volume. We have these two phases in equilibrium, right? So we would call this a saturated vapor-liquid mixture. And if we wanted to ask the question, how much water boiled, right, we could do this on a mass basis with conservation of mass. So conservation of mass would tell us that the total mass of water didn't change, and that's simply equal to the mass of the liquid phase plus the mass of the vapor phase. We could use this same argument to describe the total volume of the water, right, where the total volume is the volume that's taken up by both the liquid and the vapor phase. And that's going to be composed of, we'll call this volume H2O. It's going to be composed of the volume of the liquid phase, which is going to be the mass of the liquid phase, times the specific volume of the liquid phase, plus the mass of the gas phase, which is the same thing, going to be the mass of the gas phase, specific volume, gas phase. We can write this entire volume, right? This entire volume is just the mass of the water times the specific volume of the water. So this is equal to mass times specific volume. And we'll just drop, I guess, for simplicity, we can drop the subscripts over here, but we'll keep them down there just so that it's clear what we're talking about. Okay, so this is where quality gets in. This is where the concept of quality creeps in. So we have this figure here, figure 2.1-2, or 2.12. And we're going to take this equation that we wrote up here, right, this equation, and we're just going to rearrange it. We're going to rearrange it so that we get a specific volume equals. So specific volume equals, now the mass divided by m plus mass of the gas phase divided by m the gas phase. But we already know that the mass is equal to the mass of the fluid plus, or the mass of the liquid plus mass of the gas phase. So we can just write this as that's a plus BF plus mg so what we find there, so this is the specific volume of water. This is specifically of liquid, saturated liquid. This is the specific volume of our saturated vapor. And these two, what I'll put in parentheses here, those are simply just weighting factors. So this is just a weighted average. Okay, so we're going to introduce this thing called quality to make some of these calculations a little bit easier. So if we define this term called VFG, which you'll find in your steam tables or your property tables, right? We can find, let me change colors. So this specific volume here is just this guy. The specific volume of our saturated liquid here is this one, and the specific volume of our saturated vapor is over here. So we can describe the specific volume of our actual mixture as the combination, the weighted average of the specific volume of the liquid phase plus the specific volume of the gas phase. The easiest way to, or an easy way to do that is with this concept called quality. So in the vapor liquid region, we define quality, which will give the variable lowercase x, and we're going to define it right. The 3 equal sign means a definition. So we're going to define this as the mass fraction of our gas phase divided by the total mass. We'll put a big box around that. We're going to use this guy a lot. Okay, so the quality is the mass fraction of the gas phase. So if a quality of 0.2 means that 20% of our material, 20% by mass, is in the gas phase. The quality of 0.8 means that 80% is in the gas phase. A quality of 2 doesn't mean anything. So quality goes from 0 to 1. It can't be negative. It can't be greater than 1. It only goes from 0 to 1. So you can see it here. So a quality of 0 down here, that means we're entirely saturated liquid. If we're over here somewhere, right, this would be a normal liquid or a compressed liquid, and quality is meaningless. So we don't talk about quality unless we're specifically in this vapor liquid region. We don't talk about quality of a gas. We don't talk about quality of a liquid. We talk about quality only with a vapor liquid mixture, or a saturated liquid and saturated vapor. So it's only when you're basically on this line, on this blue line, or in between. So if we define quality this way, then our specific volume, or our weighted average, right, this is the mass fraction of our liquid, so that's just 1 minus x VF plus x VG. And we can just rearrange that to V equals VF plus, I guess this would be minus VFX plus XBG, which is VF plus VG minus VF. Okay, and we say that this guy is equal to VFG. It's just the difference in the specific volume of the gas phase and the liquid phase, right? So VFG is just the distance from here to here, so that's VFG. Right, and we define quality to be the mass fraction of the vapor phase, so it's saying, like, how far along this line are we? Are we 80% of the way? Are we 90%? Are we back over here only 10%? So if we define things like that, we get this handy equation, which we'll use all the time. So we'll define it here for specific volume, where the specific volume is the specific volume of the liquid phase plus the quality times the FG. Okay, and again, where this comes from is really that the specific volume is, as we set up here, just a weighted average of the liquid and the vapor. But now we're doing that introducing this term quality. So we'll put a double box around this one because, again, this is going to be something that we'll use a lot. So whenever we need to look at things that are happening in the vapor liquid region, right, somewhere under that curve, if we're looking at things that are happening there, we're going to be looking and using this concept of quality to be able to describe what the material properties are.